Yes. The first thing, I want you now to write the combustion reaction of C4H8O2. How are you going to write the combustion reaction?
Repeat.
Are you sharing the screen, doctor, or not?
Oh, I'm not sharing the screen yet. Sorry. All right. Before I share the screen, write this: C4H8O2. C4H8O2. Now, tell me, what is the combustion reaction of such thing?
Plus O2.
Okay. What's the combustion reaction of C4H8O2? You write the combustion reaction. Did you write it?
Yes.
How does it look?
تفكك.
That's the combustion reaction. I want to concentrate in the word what? Combustion. What's the meaning of combustion?
احتراق.
احتراق. What is it in chemistry? Reaction with what?
With
oxygen.
Oxygen. Reaction. Oxygen to make the combustion. You're burning things. Good. Now, balance this equation. Do it yourself.
Yes, mister.
Go ahead.
Can I say it?
Yes. No, just do it in your paper, and after we finish, tell me what to do everywhere.
Okay.
Outside paper first. Okay, what are you going to do to balance this equation?
The combustion would always resolve CO2, right?
What again?
It will the combustion reactions always resolve CO2, right?
The combustion reaction is, yeah, combustion always will give you, yes, very good point. Combustion is always for organic compound. Organic compound plus O2 to give you CO2 plus H2O. What's this reaction called?
Combustion reaction.
That's combustion reaction. It's a reaction of organic compounds with O2 to give you CO2 and H2O. That's it. Okay, did you balance this equation?
yes.
Yes.
What did you write here? 4 here.
Yes.
And 4 in the water.
4 for the water and
Oxygen atom in the reactant.
5 in the oxygen, exactly. 5 in the oxygen, because we have already O2 here. Always when you balance this equation, start with the carbon and then the hydrogen and keep the oxygen the last thing. Don't start with oxygen. Is this clear? Any question? In this case, always, in this case, they keep the O2 as the last thing, because if you need fraction, put fraction for O2. If you need 5/2, and then multiply everything by 2. But this time we don't need even the 2. Is this clear?
Yes.
Yes. Yeah.
Very good. Then, what is a mole? What's the mole? The mole has two definitions. Two definitions. Okay. What is the mole? The mole, one mole of any compound, any compound or element or atom or whatever, one mole of anything, any compound in chemistry is equal to what?
Avogadro number.
Avogadro's number. Keep this in your 0.22. As I said, this Avogadro's number is available with you in the periodic table, but I want you still to memorize it. Is this clear? What? Of that compound. And this is number. The compound. Atoms or molecules. Let me take this away. Keep this in your mind, and I want you to write this very clearly. Any atom or molecule or compound or atoms or whatever, or etc. This means we can say it's a number. It's a number. We're counting thing. We're counting thing. So if I ask you how many we have in certain amount, then you tell me one mole equal to this number in number. At the same time, one mole of any compound or atoms or compound equal to what? The mass of the atom or the compound in what?
In gram.
In gram. That's why if I ask you, get your periodic table now. If I ask you, what's the mass of one molecule of KSO4, K2SO4, something from my mind. What's the mass of one molecule of K2SO4? Go to your periodic table and give me an answer.
Uh, 174.27.
174.27.
27.
Who else got the same answer? I want to see more than one because I don't know what's the answer. I need your help.
Yes, sir.
Yes,
I got the same answer.
You got the same answer.
Yes.
Answer complete.
Yes.
No, it's not complete.
In grams.
Gram.
Grams.
No. If you say gram, you're wrong.
AMU.
Yes. That's important. We're talking about one molecule. One molecule. All right? Okay? And then this is what now? AMU. Keep this in mind. Very important. Now, if I say 1 mole of K2SO4, you should tell me what's the answer.
The same thing, but in gram.
Same word, 174.27, and then now I can say gram. Is this clear?
Yes.
So
Good.
JMU means certain amounts in gram for each mole.
What again?
So if I have another compound, let's say maybe it's 100 AMU, it means 100 gram for each mole.
The mole is always make the same number, but in gram. That's the difference. Keep this in your mind always. That if I'm talking about one molecule or one atom or whatever, I will put AMU. But if I say mole, then I'll say gram. That's it.
When do I multiply by the Avogadro number?
Just a second. We did not finish. Let me finish now. Now, 1 mole is equal to what? 6.023. 0.023. Times what? 10 to the power 23 of K2SO4 is equal to how many grams?
Uh, 174.
174.7 gram. Continue. K2SO4. Is this clear? Is this clear?
Yes.
Yes, it's clear.
Very good. Let me add one more information for you. When you have now equality, what can you do? I can put 1 mole divided by 1 mole of something, of X, is equal to what? 6.022 times 10 to the power 23x. Or I can say what? 6.022 times 10 to the power 23x divided by what?
1 mole.
1
1
mole.
more.
1 more.
Clear? Also, if I have 1 mole of any atom or a compound, then 1 mole X equal to what?
1 gram.
Avogadro number of that.
I already did that, Avogadro number. Now, what's this letter?
Molar mass.
Molar mass, but now I'll put gram of X. Clear? Or I can do or gram X divided by 1 mole of X. Okay, keep this in mind and memorize them very well. I'm not going to give it to you. You should keep it in anything in your mind always, and then get rid of the units. Is this easy or difficult?
It's easy.
I hope it's easy.
Doctor, again, I have one question. What is the difference between the two situations? 1 and 2.
The difference is to compare. We'll do a problem now, and let's go and do some problems. Okay, now, as I said here, what are the equations that we did already? I want you to tell me what are the equality that we did. Tell me what should I write for Avogadro's number first? 1 mole X equal to or divide by what?
Avogadro's number.
6.022 times 10 to the power 23x. Also, if I reverse it, the same thing. Which is written here, 6.022 times 10 to the power 23x divided by 1 mole X. You remember this now? What's the other equation that we did?
Molar mass.
1 mole or molar mass.
A molar mass in what?
Grams.
Gram X divided by what?
1 mole.
1 mole X or 1 mole X divided by molar mass gram X. Keep these two four relation together. Now, if I have 1 point, or I have 30 mole X, which is in this case calcium, Ca. I want you to tell me how many atoms are available in 30 moles of Ca. Which of the 4 equations you're going to use? Let's call them 1, 2, 3, and 4. Which one you're going to use to calculate how many
The
atoms?
fourth one.
4.
4. So I will say this is equal to 6.022 times 10 to the power 23 calcium divided by 1 mole calcium. Why did you use the 4th one?
To get rid of
To
the
get rid
mole.
of the mole.
Is this clear?
Yes.
Yes.
Good. Now, let me ask you another question. If I have 30 grams of calcium, how many moles is this? Which equation I'm going to use?
Second one.
Second one.
Are you sure?
Yes.
Are you sure?
Yes, second one, doctor.
Second one, definitely. What should I write at the top?
1
One
mole. 1 mole.
Calcium. What should I write at the bottom?
Molar gram.
Give me another numbers.
30 gram of
No.
calcium.
Wrong.
40.08.
40.08.
You should go to your periodic table.
40.08.
What?
40.08.
40.08 gram calcium. Write the whole thing. Not only 40.08, but write gram calcium. This way you get rid of this unit. With this unit, you have the answer in mole. I don't want mole. I want number of molecules in this 30 grams. What should I do? What's the next step?
It's times the Avogadro number.
Now, which equation should I use of the 4?
The fourth.
The fourth one.
Fourth
Now,
one.
I should say 1 mole calcium is equal to 6.022 times 10 to the power 23 calcium. All right, calcium atom. And this way, I get rid of this unit with this unit. So if I ask you how many molecules are available in gram, you have to do 2 steps, not 1. Is this clear?
Yes, it's clear.
Yes.
Any question? Good. Let's get rid of this. I want you to tell me now, if I have 1.00 times 10 to the power 20 calcium atom, how many grams is this? How many grams is this? What's the first step I should do?
Convert to moles.
We use 3.
Use
To mole.
the third equation.
Which
What's
equation
the third?
should I use?
Third equation.
Third equation. Yes, third equation. Why?
Return of mole.
Change from atom to mole.
Change to mole calcium is equal to 1 mole calcium. But you did not finish my question. I am asking how many grams is this?
Now we use
Use the first
Use the
equation.
first equation.
First one.
First one now, I should say what now? 1 mole calcium. And then what should I write at the top? 40.08 gram
calcium.
calcium. Get rid of this unit with this unit, this unit with this unit. You have the answer, final answer in gram. Give me an answer. Quickly do it. Done. Hello.
Yes, that's right.
Yes, done.
Okay, give me the answer.
6.65 times 10 to the power of minus 21.
Minus 21.
10 to
Is
the
this
power minus
correct?
3.
Minus 3, minus 3.
Minus 3.
Repeat one more time.
6.65 times 10 to the power minus 3.
Minus 3 gram.
Yes.
Who else got the same answer? I
Yes,
don't
I
have
got
this. I'm depending on you.
I get the same.
Yeah, the same.
Very good. I hope so. So you have to know how to do this. Is this clear? Now, I'm not going to write these 4 equations or equalities for you, 1, 2, 3, 4. You should keep them in your mind. I want you to solve this problem now. Determine the number of moles of carbon in 10 grams of naturally occurring carbon. So if I have 10 gram carbon, what do I am looking for? Determine the number of moles. Which equation should I use?
think
One mole of
One mole.
One mole over
Gram.
What? 1 mole what?
over the molar mass.
One more.
One mole of
1 mole carbon. You have to say 1 mole carbon. Divide by what?
Molar
divided
mass.
by
Give me the molar
12.01
12.01
gram
gram what?
carbon.
Carbon. Put the whole thing. Get rid of this. With this, you have the answer. Is this clear?
Doctor, why we don't use the Avogadro number?
You don't need to, because I'm asking for moles. Now I'll ask you, if I have 10 grams carbon, how many molecules is this?
If you ask for me for molecule, you use the Avogadro number.
Exactly. Get rid of units. How many molecules? How can I find the number of molecules? What's the next step?
Multiply by Avogadro number of carbon over 1 mole of carbon.
1 mole carbon equal to 6.022 times 10 to the power 23 atom carbon. Mole will go with mole, and we have the answer in atom carbon. Go ahead and give me the answer quickly. Do it in your calculator.
Mr. The question.
Yes.
Sorry. The question asked for moles, right?
This question is asking for mole. I extended the question.
Okay, sorry.
Yes. So the first one is the answer for mole, but I also wanted to do the same thing.
5.01.
5.01.
10 to the power 23.
5.01 times 10 to the power
23.
23 gram. Sorry, atom carbon. Is this clear? Is this clear?
Yes.
Right. Now,
AMU دكتور.
mass of naturally the molar mass of sodium chloride NaCl is okay. Oh, B. Okay, we'll solve B. The mass of 0.905 mole of sodium chloride. So if I have 0.905 mole NaCl, what's the question is asking? The mass. So what should I do? How to solve this problem?
Multiply by the molar mass over 1 mole.
Well, give me a number. Molar mass of what? NaCl.
58.44.
44 gram NaCl. You get it from your periodic table, even though it's available here. Okay, divided by 1 mole NaCl, and then get rid of this unit. This unit, you have the answer. Okay.
44.7.
44.7. Is it?
0.76.
No, it's not fine.
That's 52.9
Yes, 52.9
gram in
NaCl.
ACL.
Good. Now let me ask you another question. If I have 0.905 mole in NaCl, how many molecules is this? What should I do?
Multiply by Avogadro over 1 mole.
Number over 1 mole.
Divided by 1 mole NaCl. And then you get rid of this with this, and you have the answer. Give me answer quickly.
5.44.
5.44 times 10 to the power
23.
23 gram NaCl molecules. Is this clear? How easy?
دكتور, can I write AMU?
No, don't write AMU. I'm not asking about how many atoms I'm counting. I'm not saying what's the mass of this thing. Is this clear? I'm counting. When I say how many fingers you have, what are you going to say?
10.
Okay, 10 grams or AMU?
AMU.
AMU.
No, it's not AMU, it's not gram.
10
10 numbers only. Exactly the same thing here. If I say 1 mole of NaCl, how many NaCl molecules is there? What are you going to say? Just Avogadro's number, 6.022 times 10 to the power 23. What's the unit?
NaCl atom.
NaC atoms. Fingers, like fingers. Is this clear? I hope it's clear.
Yes.
Yes, it's clear.
Avogadro is just number. We can count things with it. A mole, we can change it to mass. The mass, we need to put gram because we're weighing. But when you say just mole, this is the definition of mole, either numbers or mass. If I ask you about how many, then don't put any unit. No AMU, no gram, no nothing. Is this clear?
Doctor, is Avogadro number exact number?
Exactly. No, it's not exact because it's not. If you put it full with full numbers, it will be exact number. Exactly. Yes, it is exact number like fingers. But if we have it correct 100%, Okay. Okay. Now,
Okay, yes.
let's solve, determine the number of water molecules and the number of H and O atoms are in 3.26 gram of water. We have 3.26 gram H2O. I want to know how many molecules of water. How many molecules? Counting. What should you do?
Avogadro's number over.
Oh, convert more.
No, convert it
No,
to
2 mole
mole
convert
first.
first.
1 mole over
What should I write at the top?
1 mole.
1
mole.
H2O divided by what?
molar 18.016 grams of H2O.
0.016 gram. What?
H2O.
You have to say H2O. Get rid of this unit with this unit. Am I done?
No.
Not yet.
The number of water molecules. So he's asking about number. So what's the next step?
Avogadro's number of H2O molecules divided by
1 mole of H2O.
1 mole of H2O.
Times 10 to the power 23 H2O molecules. Divide by what?
1 mole H2O.
1 mole.
1 mole H2O. Done. And then I need the answer.
1.08 times 10 to the power of 23.
0.9 times 10 to the power what?
23.
23. Continue. I'm not finished.
H2O molecules.
You have to put the full name, H2O molecules. Is this clear? Is this clear? Good.
Yes.
Number.
Yes.
Now let me ask you another question. How many oxygen atoms are there in this amount? So if I have 1.09 times 10 to the power 23 H2O molecules, how many hydrogen atom now? H atom.
Multiply with
times
2.
What should I write?
2 times 1.09 times 10 to the power of 23 H2 atoms.
So what
Or
should
H atom.
I will say 2 hydrogen atom for each what? 1 H2O molecules. Right? In each H2O, there are 2 hydrogen atoms in each one H2O molecule. Correct or wrong?
Yeah, it's correct.
Correct. So what's the answer in this case?
2 times 1.09 times 10 to the power of 23.
8, 2 times, so which is 2.2818 times 10 to the power 23 H atom. Okay, if I want to know how many O atoms are there,
Multiply by 1 O atom over 1 H2O molecule.
10 to the power 23 H2O times molecules times what?
1 O
1
atom,
O
Times
atom
1.
for each
H2O molecule.
1 H2O molecule. Get rid of this with this, and you have the answer as 1.09 times 10 to the power 23 O atom. Don't forget to write the whole oxygen atom, the whole process. Is this clear? Okay,
Yes.
done with this. Okay, let's solve the other question. Determine the mass of 7.92 times 10 to the power 19 carbon dioxide molecules. What should I do? What should I write?
Convert to mole first.
Convert to mole then.
I write whatever is given to me. 7.92 times 10 to the power
19.
15. What?
CO2 molecule.
CO2 molecules.
Multiplied by
Multiply by 1 mole CO2.
1 mole CO2 divided by what?
Avogadro number.
Avogadro.
6.022 times 10 to the power 23 CO2 molecules. Get rid of this with this. Am I done?
Not yet.
Not yet. Why?
I mean,
The mass.
Convert it to mass. So I should multiply it by this. What?
12.
Huh?
44.01.
44.01 gram CO2 divided by what?
1 mole.
1 mole of CO2.
CO2. Get rid of this unit with this unit, and you have the answer. How easy?
So easy.
Very easy. I hope so. Let's hope that this is always true and this is the case. Okay. Empirical formula and percent composition. Empirical formula and percent composition. What's the empirical formula? What does it mean?
The simplest formula.
Simplest form.
Empirical formula. What's the empirical formula for C6H6?
CH.
CH. Exactly. What's the empirical formula for N2O4?
NO2.
So it's simply we divide it by, if there is a common factor between them, we take it away. That's the meaning of empirical formula. Next question. Okay, next question. What's the percent composition? What do you mean by the percent composition?
The percent of every atom to the whole compound.
If I have NO2 molecule, what's the percentage of N in this compound? How can I find it?
1/3.
What?
1/3.
No! Percent composition by mass.
The mass of nitrogen.
What should you do to find the percent composition?
The mass of
The mass of nitrogen over the mass of
whole mass.
What's the mass nitrogen divided by what?
Mass of the molecule.
Mass of NO2 molecule. Okay. What's the mass of nitrogen by itself?
14.01.
What's the mass of NO2? Yes.
6.01. 46.01.
46.01. Go to the periodic table and find the mass. And then I should multiply this by what?
100.
100 to give me the percentage. What's the percentage?
30.45.
30.45. So that's how you find the percentage. That's how you find the percentage. Is this clear? Now, I'm going to reverse this process. I will, in the next question, I will give you the percent composition, maybe this one or anything else. Okay, I want you to find what's the empirical formula. This means I will reverse this process and I will tell you how to do it. Okay. Now, determine the empirical formula for a compound that is 30.45% nitrogen, and naturally, I will say, if I don't give you this number, can you find it?
Yes.
How can you find it?
Yes.
100
Minus,
minus.
100 minus 30.45.
Subtract from.
Subtract this one and you find it. Clear? Let's go back to our question. When I say 30.45, what's the percentage of oxygen in this compound?
100 minus 30.45.
100 minus
69.55.
30.45, and the answer is 60.
69.55.
9.55 exactly percent oxygen, 30% nitrogen. That's the first thing you should know. So if I give you this question, I did not write this. Determine the empirical formula for a compound that is 30%, 30.45% nitrogen, and it consists of only oxygen and nitrogen. This means the percentage of oxygen is 69.55. How to do this problem? Be careful with me now. The first thing you should put here nitrogen and oxygen. Sometimes you have more than 2 atoms, put all the atoms. Maybe we will have solve a problem in a while in which we have carbon, hydrogen, and oxygen, or carbon, hydrogen, and nitrogen. Is this clear? So why did I write only 2 atoms?
For the empirical
Because the
formula.
compound
Has
has
two atoms only.
And oxygen. Clear? Next. The thing, I will assume that this is 30.45%. It is without unit here. Go back to this one. This is without unit, and this one without unit. This is percentage only. No unit. Why is it unitless? Why is it unitless? Because the mass here in gram and the mass here in gram, or the mass in AMU and the mass in AMU, in all cases, what will happen? The AMU will go away, or the gram will go away. Is this clear? So what's the mass? It's 30.45% in what's the unit? Yes? What's the unit here?
Unitless.
Unitless. I want to hear this. Unitless. What does unitless means?
Don't have any unit.
Doesn't have a unit.
Very good. I'll go back to this one. So what's the unit for this one?
Unitless.
Unitless.
No units.
Unitless.
Unitless. I will assume that I have 100 gram compound. 100 gram compound. Then in this compound, how many grams of nitrogen are there?
30.45.
30.45.
And what's the unit now?
Gram.
Gram nitrogen. Good. How many grams oxygen?
69.55
gram oxygen.
Oxygen. Yeah, of course. Oxygen. Yes. I will put these numbers. Now, I want you to do the same. Do this one. 45 gram, and I will write here 69.55. And I will write here mass. Okay, then I will change it to mole. I want you now to change everything to mole and give me the answer.
2.17 moles of nitrogen.
How did you do it?
I multiplied by 1 mole of nitrogen over 14.01 grams of nitrogen.
So what's the answer?
2.17 moles of nitrogen.
Mole N. And this is gram N. Be careful. And this is gram O. Now, can you find the mole of oxygen?
Yes, 4.34 moles of oxygen.
4.34 mole oxygen. Okay. Now, get rid, the next step, okay, that's step 1, that's step 2, and now I'll go to step 3, and I will say divide by smallest number. Which one is the smaller number?
2.17.
So what are you going, when you divide by 2.17, what are you going to get here?
1 to 2.
That's the empirical formula. What's the empirical formula in this case?
NO2.
NO2. Is this clear?
Doctor, I have a question.
Yes.
How did you convert the percent to gram?
Because I assume that I have 100 gram.
So always I assume that 100 gram the compound.
Yes, of course. Or you can assume that you have 1 gram and then you'll have everything in point something. Somebody can say, no, I don't want to assume this. I will assume that I have 1 gram compound. Then what will be the amount of nitrogen in this case? If I assume I have
0.3.
0.3045. Is this clear?
Yes.
Yes. You can assume either this one or this one. It's up to you. But you assume something and you build in it. Do you know how to find the empirical formula from the compound?
Yes.
Yes, clear, doctor.
Good. I hope it is clear.
Doctor, in the last slide, you divided what by what?
What is it?
Yes. It's nitrogen over 30.45.
Nitrogen over 30.45. No, how do you change mass to mole?
You just multiply it by the number of. Okay, I understand now. Thank you.
Are you sure?
Yes.
Good. Okay, now determine empirical formula, determining the molecular formula. Now, this is very known experiment for organic compound. So we take organic compound, put it here, and then we burn. When we burn organic compounds, what are you going to get from burning any organic compound? What's the organic compound consist of?
Carbon and hydrogen.
Hydrogen and sometimes oxygen. Okay, and this is X, Y, and Z. Sometimes, whatever. Maybe there is oxygen, maybe there is no oxygen. Let's assume whatever. Okay, when you react this with oxygen, what are you going to get?
H2O,
CO2,
water and carbon dioxide.
And
What? H2O.
Water, H2O.
all right.
And
How much? What are you going to put here beside the C if I want to balance it?
X.
X here and
Y after before H.
here, and it's now balanced. Okay, excellent. Now, all the carbon that come from here is available here. So if I know the amount of carbon, I can tell how much carbon is available here, right?
Yes.
All the hydrogen that's available here come from where? Here. And I can, if I know the amount of hydrogen, I can tell how much hydrogen is available here. But the oxygen, is it all coming from here?
No.
No, why not?
From both.
From here.
There is 2 sources.
So I cannot tell if the oxygen here, this oxygen is not coming from the compound. It's coming from the compound and from outside, if there is oxygen in it. Is this clear?
Yes.
Then we want to determine the empirical formula. Based on this, we want to determine the empirical formula. Okay, let's do this question. Combustion of 5.5 gram sample benzene produced 18.54 gram CO2 and 3.81 gram H2O. Okay, I want to know the empirical formula. Find the empirical formula for this compound. Okay, this compound is consisting only from carbon and hydrogen. So this is X and this is Y. We reacted with what now?
Oxygen.
To make what?
Carbon dioxide and water.
CO2 and Y H2O. Good. If I have 18.59 gram CO2, how many grams of carbon is available in carbon dioxide? How many grams of carbon only?
12.01 over 44.
I'll help you. There will be 12.01 gram carbon in each 44.01 gram CO2. What I wrote is wrong, right or wrong?
It's right.
Why?
Because that is what we have when we look at the CO2.
Mass of CO2 is 44.01, and there is only one atom of carbon, which is 12.01 gram carbon. This way, find the mass of carbon. Give me an answer.
5.07
5.07. Continue.
gram carbon.
3 gram carbon.
Mister, I have a question.
Yes.
If we are looking for the oxygen, we will multiply in the numerator with 2, right? Because there are 2 atoms.
2 times 60 times 16.
Yes.
Yeah, it will be 32. This means,
Okay.
right, you put the denominator 32 divided by 44. Exactly.
Okay, thank you.
Okay, if I have 3.81 gram H2O, how many grams hydrogen is there?
Oh, we divide.
Times 2.008 grams of hydrogen.
16.
What should I, 2 times what?
2 times 1.008 grams of hydrogen over 18 over 18.016 grams of H2O.
Exactly. Give me an answer.
Zero point
0.426 gram hydrogen. Exactly. Now we know the carbon and we know the hydrogen. If I put carbon and hydrogen, I want to determine the empirical formula. What's the first step you're going to do? You put here mass. What should I write under carbon?
Mole.
5.7.
5.67.
Carbon divided by here 0.426 gram hydrogen. Next.
Change it to moles.
Convert to mole.
Mole.
Divided by 12.
Give me answer.
0.422 moles of carbon.
2 what?
Moles of carbon.
Mole carbon. Okay, give me hydrogen.
0.422 moles of hydrogen.
422 mole hydrogen. Okay, what's the next step?
Divide by smallest number, 1 to 1.
So divide by smallest number. Which one is the smallest number?
They're
0,
both.
4, 2, 2.
Same.
Which in this
Will be
case
1 to
will be the 1 to 1. And what will be the empirical formula?
CH.
CH.
H. You don't have to put 1 to 1. How easy?
Very.
Very easy.
Can you do it for any organic compound? Sometimes there will be also oxygen, and then you have to put, or nitrogen. Don't forget to put the mass of oxygen or nitrogen in the third place as well, if there is need. Good. Now, we know this is the empirical formula. What's the mass of this empirical formula? What's the mass of this empirical formula? The molar mass.
13.09.
13.0.
0.09
Grams
is the empirical formula. Clear?
Yes.
Are you following?
Yes.
Okay. Now,
how am I supposed to know if it was carbon and hydrogen and oxygen?
what again?
How am I supposed to know if it was CHO?
I did not get your question. What's your question?
Doctor, we took an example before about CHO plus O2 as combustion at the start of the class.
Yeah. In this case, we don't have O, so it's only C and H. If there is O, you put O. If there is N, then you put N. If it depends on the question.
And how do I know that?
It depends on the question. You read the question. We will give example in which there is oxygen after a while.
Okay.
Here, very good. Now, I want you to know that empirical formula is CH. The mass of the empirical formula is 13.09. How to find the molecular formula? How to find the molecular formula, which is this one.
Make 13 equals 17.
See, I will give you determine the empirical formula. We want the molecular formula M of benzene, given that the molar mass is 78. So the molar mass, I'm giving you the 78 here, and so you should take the molar mass that I gave you, 78, divided by the molar mass of the empirical formula, which is 13.09. And what's the answer? 6. And then you can say, what's the molecular formula? You take this number and multiply it by the numbers that you have here. And so what's the molecular formula? C6H6. Is this clear?
Doctor?
Yes.
For the 78, it will be given in the question or?
Yeah, exactly. The 78 will be given in the question. Good. So you take whatever is given to you in the question. Sorry. You take whatever available for you in the question, divided by the molar mass of the empirical formula, which we calculated 13.09, which is 12.01 plus 1.008, and it became 13.09. Clear? No.
Yes, it's clear.
Anyway, and then this should be 13.02, not 1. Somebody gave me 9, but it is 2, isn't it?
Yeah.
It's 2, right? Yes, right.
Okay, 13.02. So you divide 78 by 13.02 and becomes 6. So the empirical formula, I multiply whatever here times 6. So it is C6H6. Is this easy?
Mr. The empirical formula will be CH, right?
The empirical formula is what?
Is CH.
Yes.
Not C6, H6.
Of course, the empirical formula is CH.
Okay.
The molecular formula is C6H6. I have to divide the mass that's given to you by the molecular formula, divide by the empirical formula number here, the mass of the empirical formula, which is 13.02, and you get this number, and you say, this is the molecular formula, and this is the empirical formula, C1H1. I hope this is clear. Yes.
Please, how did we get 13.02?
13.02. What's the mass of carbon in the periodic table? Go to your periodic table.
Oh, it's 12.01.
How about hydrogen? Yes?
Yes, thank you.
Okay. Okay.
Doctor, how do you know that benzene is CH?
That's what we did. That's the whole calculation here to make CH. Do you know how to do this?
Yes, I know, but do you have to memorize the formula of the CH?
No, you have to memorize that you have one here and one here, and this means it is CH. Why did you put here one in O2? One here and two here. That's why it is 1 NO2. Is this clear?
Oh, yes. Thank you.
Let's go to another reaction. When we have such reaction, 2CO with O2 to give you CO2. What's the information that I have when I have this equation? I can very easily say that 1 mole CO react with what? So,
2 atoms of oxygen.
1 mole. 2.
1
1
mole of oxygen.
Because, yes, I
1
can
mole.
say 1 mole of oxygen or 2 to give you
2 mole.
2 mole of CO2. Is this clear?
Yes.
Okay. By the way, they always write the mole without the E. But if you write the E, it's okay. But if you don't write it, that's the way the science, how we write in science, mole. Is this clear? This is not important. But you have to keep this in mind. Don't say that, what's this mole? It's mole, but they don't usually write the E. Anyway, now let's look at this formula. Okay, if I can relate things here very easily. I can say each 2 mole of CO needs 1 mole of O2 to give 2 mole CO2. If I have 10 mole CO, how many mole oxygen do I need to react with it?
5.
5 mole.
5.
How many mole O2? How many mole CO2 I'm going to produce?
10.
10.
10 mole CO2. Yes, absolutely right. How about if I have 0.2 mole CO? How many moles do I need from O2?
0.1.
0.1.
0.1 mole O2. How many moles of CO2 I'm going to produce?
0.2.
0.2 mole CO2. Okay. How about if I have 10 grams CO? How many grams of oxygen do I need?
5.
Wrong. Very wrong.
20.
Yes, we need to convert.
Yes, you cannot
Convert it to
deal
mole.
with grams. You cannot deal with gram. You have to change it to mole. What's the first thing you should do?
Multiply by 1 mole over Avogadro's number.
Let me answer. 10 grams CO, how many moles is this?
0.38.
0.38 mole CO. Who got, anybody got the same answer?
0.357, yeah, that's correct.
Oh, 38, very good. Very good. Now, how many moles of O2 is there?
Zero point
0.15.
No, not 38, wrong.
19.
0.19.
19. Don't forget, we always divide by 2. Clear? And then, how many CO2 I'm going to produce?
0.38.
0.38.
8 mole CO2. Now, how many grams of oxygen do I need? I have this mole. Oh, how many grams of oxygen do I need? Yes?
3.04.
3 point what?
04.
0. Are you sure?
No, 6.08.
0.2 times 32. 0.2 times. No, it should be this number. You multiply by this number times what? 32.
Yes,
6.08.
6.08.
Okay, so okay. 6.008. 6.08 gram O2. Don't forget, O2, not O. Is this clear? So I can relate things by mole. When you have equation, I can relate things by mole, and then I can calculate grams. Is this clear? Okay, let's solve this problem very quickly. Here I have NH3 plus CO2 to give you NH2CO plus H2O. This is already balanced equation. So what information do I have already?
How many moles? 2 moles.
2 moles NH3 needs what?
1 mole CO2.
1 mole.
1 mole.
CO2 to give you
1 mole.
1 mole NH2 twice CO plus
1 mole water.
1 mole for
1 mole water. I know this. Let's solve these questions very easily. If I have 5.25 mole ammonia, what will be the amount of urea that will be produced?
5.25 moles of ammonia.
5. This is urea. This is urea. Okay. If I have 5.25 mole NH3, 5.25 of this one. How many moles urea?
2.625.
2.625. How did you find that?
Divide by 2.
Excellent. Okay, let me ask you another question. How many moles of H2O you're going to produce?
2.625.
5, exactly. Good. Determine the stoichiometric amount of carbon dioxide required for 525. If I need 525, how much CO2 do I need?
It's 2.625.
25. Don't forget this. Okay, now let me ask you another question very quickly. If I have if I have 10 grams, 10 gram urea, then how many grams, sorry, 10 gram ammonia, how many grams urea I'm going to produce? What's the first thing you'll do?
Convert to moles.
Exactly, change it to mole quickly.
0.58 moles of
divide
NH3
what?
over the molar mass of NH3,
Which is what?
which would be 14.01 plus 3.27. 3.027.
Which is 17.03, right? Give me an answer now. Divide this by NH3.
0.58.
0.587
8, yes. Or 59, yes.
small. 58 or 49? 59.
59.
59.
Sure?
Yes, 59.
Okay. Because what did I do? I divide this by about 17. Divide this by 17, which is the molar mass of NH3. N is 14.01 and hydrogen is 3 times 1.008. Add them together, it will be 17 something. And then you divide this number 10 by this and you have it in mole now. Good. How many moles of urea I'm going to produce?
It will be 0.29.
295 mole urea. Great. Can you change it to gram?
Yes, definitely.
How?
Multiplied by
molar
mass.
Yes.
Molar mass over 1 mole.
Nitrogen, 2 nitrogen. The mass of nitrogen is 14.01. 2 times 14.01. And then you have 4
hydrogen
times, which is 4 times 1.008. And then what do you have? 1 carbon, which is 12.01. And then you have 1 oxygen, which is 16.01. Oh, sorry, 00. Add them together.
40.3.
40 point what? 3?
3.
3. What's the now change mole to gram? Can you change it?
Yes.
Which is what?
Multiplied by 0.295.
Exactly. Give me answer.
$11.88.
11.89 gram urea. I call it urea. See, 10 grams produce 11 grams. Not half of it. More of this one than this 10 gram NH3 produce 11.89 gram urea. Now, if you have any chemical equation, you can compare things only by what?
By mole.
So whatever mass you have, change it to mole and then change the mole to gram. But you cannot compare things by
grams.
Is this clear?
But doctor, it should be balanced, right?
Of course it should be balanced. Of course. Okay. Now I will stop here. Okay, but I will continue. I will open the attendance. I will continue with this equation in a while. Let me open the attendance first. Okay, good. Now, let me do it very quickly.
Doctor,
Yes.
about the last question, I get 70.7 gram for the urea.
No, it cannot be. You're wrong.
Yes, doctor. I think they forgot to multiply the nitrogen by 2 and hydrogen by 4.
Yes, doctor, I did that, and I get 60.
Yeah, same thing.
Molar mass.
I got 60.062.
Exactly.
Yeah,
right.
that's correct.
That's the correct answer.
The site is open now. I want you to make attendance first. Okay. Let's see. Okay, let's open it one more time. Okay. I said 10 grams of this one. 10 gram NH3. And you should tell me how many moles is this. Give me an answer. You divide by 17.01.
It will be 0.59.
Yes, then you divide it by 2.
59. Now I know mole. Mole I can compare. If I have mole NH3, I can tell how many moles urea do I need. I divide by 2. It will be 0. What?
295.
295.
295 mole urea. Now I want to change it to gram. As I said, we have an urea. We have 2 of nitrogen, which is 2 times 14. I'm not going to write 2 times 14.01 plus 4 times 1.008 plus 1 times 12.01 and then plus 1 times 16.00. Add these numbers together. 28 plus 4, 32 plus 12, 50.
It will be 60.062.
66, I think. Only 60?
60.062.
Who got the same answer?
Yeah, it should be all
Yeah,
of
I
us.
got
I get the same answer.
Yeah, the same.
Multiply this by this math. What are you going to get?
17.71.
17.71. Who else got the same answer?
Yeah, I got it.
Yes.
Yeah, the same.
It is possible. So it was wrong in the first time. Okay, let's go back. Let's go to this problem now. Nitrous oxide, calculate the ammonium nitrate that must be heated in order to produce 10 grams of nitrous oxide. We want to know how much grams of this one we need to produce 10 grams of this one. First, this is the equation and it is balanced. How to solve this?
You change it to mole.
You have to change it first. This 10 gram, change it to mole. How are you going to change it to mole? Don't forget the nitrogen is equal to what?
14.
14.01.
15.01 and then 1 times
16.00.
Add them together. 28 plus 16 is 44, isn't it? Yeah, 44.01. Right? Then how many moles is this?
0.22.
0.2.
Yes, moles of N2O.
Divide by 44.01. Who else got the same answer?
Yes, I got the same answer.
This mole. Now I can compare. How much of this one do I need in mole?
0.22.
It
will be the same.
Same because it is 1 to 1. Very good. Mole NH4 NO3. And this is mole
Doctor,
O2. Yes.
By the way, nitrous oxide, is it the common name for N2O?
No, that's not the common name. There, yeah, this is the common name, yes. It should be dinitrogen oxide if you want the official name. But the nitrous oxide is very well known as nitrous oxide. And it's used as an anesthetic. You know what's the meaning of anesthetic?
مخدر.
مخدر.
Okay.
But this is the commercial name. This is the commercial name. All right, good. How many grams is this one? Now we have nitrogen is 14.01. 4 hydrogen is 4 times 1.008 plus, oh, sorry, 2 times 28 because we have 2 nitrogen. 2 times 18, and then we have 3 times 16.00. Add these numbers together.
80.05.
Who got the same answer? 80 point what?
05.
05. This means how many grams is this one?
17.61.
17.61 gram. Anybody got the same answer?
Yes, I got the same answer.
Yeah, I got it.
Not 17.
Doctor, I have a question, please.
Just a second. And,
Doctor, the answer should be 18.2.
Yes. It's not 17, that's why I'm saying. It's not 17.
Because of
Maybe because of the rounding.
Wrong.
The answer is
the mole
supposed to be 18.169.
17.61. I got this answer.
Yeah, just a second. Let's do it one more time. Don't do rounding. Let's have many numbers. If I have 10 grams, divide this by 44.01. What's the answer?
It's
0.227.
But we write
that's
only.
fine. 227, that's a big difference. Now, this is 0.22, also 7. Good. Now multiply 0.227 times 80.05.
18.2.
18.2?
Yes.
Yes.
This compound, ammonium nitrate. Ammonium nitrate. Is it?
Doctor, we can do it all in one step, right?
You can, whatever you want. I want you to deal with moles only. That's the most important point.
Doctor, how many numbers do we take after the decimals to be accurate?
Oh, take and the calculation, if it's not significant figures, which is, there will be only one question about significant figures. Otherwise, always use all the numbers. But even if you do the numbers, you have to be careful. I mean, somebody told me 0.22, even though it's 0.227, it should be 0.023. So if you make it 7, it will be, of course, wrong. If you forget about the 7 without rounding. But in the exam, always use at least 4 significant figures or 4 figures after the decimal. It's better.
Okay.
Here.
Is there anything more, Doctor? Can we leave now?
Yeah, of course. I took the attendance and the time is over, so you can leave. Yes.
Yes, I know. Just if we have more information. Yeah, thank you very much.
Okay, I will stop the recording now.
Mr. When will you upload this lecture?
Oh, Sunday, inshallah.
Sunday?
Yeah. I mean, Sunday, Monday. Monday, not Sunday. What's Sunday? I forgot about Sunday.
You will upload it on Monday?
No, upload the lecture today, inshallah.
Okay, thank you.
Let me stop recording first.
Doctor, can you go back to the previous question?